Hey everyone, welcome back to my channel. Today we're going to tackle problem number 75 on LeetCode, which is all about sorting colors. Now, you might be wondering why this problem is important or interesting. Well, the reason is that it's a classic example of how to approach complex problems by breaking them down into smaller, more manageable parts. In this video, we'll go through my thought process as I develop my own idea for solving this problem. We'll cover the key concepts and steps involved, and I'll provide examples and analogies to help you understand the material better. By the end of this video, you should have a solid grasp of how to approach similar problems in the future. So let's dive right into it. Problem number 75 on LeetCode asks us to sort an array of colors where each color is represented by an integer. The catch is that we can only use one extra space, and we need to do it in place. At first glance, this problem might seem daunting. But, as with any complex problem, the key is to break it down into smaller parts. Let's start by thinking about how we would approach this problem if we didn't have any constraints on space. One possible solution is to use a counting sort algorithm. This involves creating an array of counters where each counter represents the number of times a particular color appears in the input array. We can then use these counters to construct the sorted output array. However, this approach uses extra space, which isn't allowed according to the problem constraint. So, we need to think of a way to do it in place. Here's where things get interesting. What if we could somehow modify the input array itself to represent the sorted output? This would eliminate the need for any extra space. One possible approach is to use a technique called Dutch national flag algorithm. The idea is to partition the input array into three parts, one part containing all the zeros, or red colors, one part containing all the ones, or colors, and one part containing all the twos, or blue colors. We can do this by maintaining 4 pointers, 2 for the zeros, 1 for the ones, and 1 for the twos. We start by scanning the input array from left to right, and whenever we encounter a 0, we swap it with the element at the next available position in the zeros partition. Similarly, whenever we encounter a 1, we swap it with the element at the next available position in the ones partition. And whenever we encounter a 2, we swap it with the element at the next available position in the twos partition. By doing this, we effectively sort the input array in place without using any extra space. So to recap, here are the key points from today's video. We approached problem number 75 on LeetCode by breaking it down into smaller parts and thinking about how to solve it without constraints on space. We then adapted our approach to fit the in-place constraint by using a technique called Dutch national flag algorithm. This involved partitioning the input array into three parts, one part containing all the zeros, one part containing all the ones, and one part containing all the twos. We used 4 pointers to scan the input array from left to right and swap elements whenever necessary. And that's it for today's video. I hope you guys found this explanation helpful. If you have any questions or need further clarification on any of the concepts, please let me know in the comments below. If you liked this video, be sure to like it and subscribe to my channel for more content on programming and problem solving. And if you want to see more videos on LeetCode problems, let me know that too. Thanks for watching, and I'll catch you all in the next video.